Okay, so here we are on this Codevember session number 17. We are live on Instagram, we are live on Twitch, and my tea is pretty hot. So yesterday we made this little guy here made of some wood log and having some fur, etc., etc. This scene seems to have some bugs. Sometimes the fur glitch, sometimes the also the display one does not work. I don't know why. If I set the camera to display one, I don't know why it will stop working. So I have a gray element here. I've just seen someone saying it might come from the post-processing stack, but I'm not sure about this one. Maybe I've changed something on the post-processing. I'm not sure. So this is, it's global, it's everything. I don't know. I have this main problem because if I basically change the display, it's working pretty well, in fact, as you can see. So does this problem come from the camera capture? I don't know. I had an FFmpeg yesterday, an FFmpeg error yesterday, so maybe it's a problem, and so yeah, this was the scene from yesterday, and I'm quite fond of this one. I think it's really interesting, and I think I want to explore more some wood-based man. But I have this idea since few days ago, I think, where we have a man made of some wood sphere, a man or a woman, I don't know, some humanoid shape, of course, made of wood ball, and the ball, the sphere, might grow, and then when it reach its size, it will fall down and bounce on the ground. I'm not sure about this idea. I'm not sure if I would be able to produce this idea tonight, because we might need a lot of elements inside of the compute shader. So I'm not sure about that, but let's try this one. So let's try to duplicate. In fact, let's try to duplicate a walking scene, not this one, because this one has some errors. So this one, I don't know why on display one seems to be working pretty well. So yeah, this one is working. So I think I will start with this one. And of course, this means that we have end our experiment. We have reached the end of our fur experiment. So let's try something new. So yeah, let's name this scene 11:17. You might notice that we've changed the theme of our music. We are not playing some jazz anymore. It's a new playlist called Wake Up and Smell the Coffee. Found it pretty interesting, but maybe we will change by another one. But it's good for this one. And on Twitch nobody can listen the music because Twitch has some issue with the rights on music. So it's our 17th scene, and we have a lot of different script, and we can get rid of each of them. So let's remove all of them right now. Okay, that's our based element. Oh, I have a streaming asset. Yes, if you peg out. Okay, California. Okay, for this one, the controller is okay. Now the GPU mesh controller will be okay. Okay. Let's start with 100 of instances. We'll take a nice sphere. We have this one here, the unity sphere. Let's start with a scale of 1 by 1. I think it might be too big, but do not rotate the shape right now. And as we're working with the scene 11, I think the shader 11 might be blah. Rename. So we might fork this shader 11. Okay. So let's put in Agati here. Okay. And then we will need a compute shader. Out of something I just fall from my desk. So okay. Okay, let's modify a little bit this compute shader, and we will not modify the velocity and all this data also. Okay, not bind this, only working with this. So let's try this one. Okay, a big ball man. So let's try to change this a little bit. Let's say we want a max size of 0.71. Maybe we can have some more. I want to have some nice. So first of all, let's change the material of the shader. So this is this one. Just to be sure, let's modify our. Let's fork this shader here, so it's E11, and we will change it a little bit because we might maybe bounce some light. Okay, let's get some nice yeah, this is the error I get, so I think okay, I will check another time. So I think I will go with this one. It's created with Substance Designer. It's this one or this one might be better, I think. There is another, yeah, there is some wood floors that might be interesting to add some ball based on a wood floor, having some pattern inside the ball. So this one, or something more like that. I think I would go with this one. Okay. So let's create a new folder and let's call wood floor. Okay. Okay. So the color, the double click. No more. We have an ambient occlusion here. We have some rudeness, and I think the metal will be a black, so let's use that. So yeah, that was basically that was what I had in mind at first when I wanted to play with some nice furball. So we still can play with the glossiness, etc, etc. So you can see we can play a little bit with the glossiness. It's not perfect for tiling, especially here, but we might change it. Maybe we can change it. It's on repeat. Maybe we can mirror. So if we tile the texture, it will be mirrored and the tile will be preserved. Another thing we could play with um, let's change a little bit. So let's transform this as a range, in fact, from 0 to 1. This would be 0 because we still have the ruggedness, so not a problem. This would be a float. So this would be this. The ruggedness, I think it doesn't need to be multiplied by the glossiness, and I think we can get rid of the glossiness. No 2D matching parameter here. I will also change the reflection in order to retrieve properly the yeah, so now it's okay. So yeah, I will also change the emission to retrieve properly the MIP mapping from our little cube map. Let's retrieve with the proper tiling for every element. So this is really the texture we have downloaded. So we can put some metalness inside it. So the glossiness is really not useful. Okay. Then as we saw, we will change the 16.2. Yeah, it was this one. No, or the 16. Where do we have? Yes, we have this. Okay, so we need to change this by that. Okay, so it's basically the cube using the word reflection, but instead we will use the on-zero blur multiply by the global emission, so it's not a problem. We could get rid of this one for the moment just to check and add an environment blur instead of the glossiness. Okay, and add this little float here instead of the glossiness. Okay. So now we have what I wanted. So if we put some metallic into it, you will see it's get a little bit more. It has some more metal. And this is the reflection, but we can blur, of course, the reflection and reduce this in like I think 0.3 might be good. and we can add our little emission. So the problem here is if I use that, I will multiply everything, so I'm not sure about this one because it's basically a multiplication. As you can see, it's really, it has a little bit of an impact on it, but especially on the color of the emission, not really on the proper emission. So I think I would get the same system we've made yesterday, so simply by taking the albedo multiplied by the emission, just add a simple additive layer to bring more color into it. Something like that, I think so. So for me it's good. I love the alpha test. Okay, so for me this part is good. Now we can work on the let me re-show you the elements. So now we can work on the volume distribution. What I mean by that is you can see it here. Right now we are really small on the feet, then growing around the legs, then be fit on the belly, and then we will regrow basically on the head. We have this kind of curve going from the base like that, more something like really like that, but maybe I think I could be able to bring a little bit more volume directly on the belly and not on the legs, so this could be interesting. So basically it's everything is happening on the compute shader. I will simply need to offset this. So if I get rid of this little multiplication here, we only have this kind of curvature, so you know, base, so base, middle, top. So because we're going from, remember, the floor is 0, the top of the head is 1, so we're going from 0 to 1, and we basically have some kind of curve around this value, so 0, 0, 5 and 1. So basically now the base element, the maximum size happen on 0, 5, and that's what I want to offset a little bit. So I want to think about it. So yeah, something like that. But I might want something going from that and directly reopen it. So how can I achieve that part? Maybe by simply reducing this, you know, do you think the value, and if I augment the value by 2, I think I need to draw my curve. So let's try to think a little bit about this curve. So we have something like that going from 0 to 1, and right now if I'm taking everything correctly, so I know the maximum size is 1.8, which is basically the max position of one of the sphere. So now I have something using, I don't remember which curve. Yeah, we use an exponential. So yeah, so we have something like that, and everything happening around the 0, 5. You know. So if I want to change a little bit these parts, this would be having some 1 here, 0, and maybe something like that. You know what? Let's disable these parts. So let's only not get, but let's keep only the linear shape. So okay, this is 0, 5, not a problem. So maybe I want to rescale it a little bit. So I can use some mix, some linear interpolation. So I can simply say if I go to 0 to, I don't know, some kind of value like 75, this would be from 0 to 1, and then if I go from 75 my point to 1, I will go to 0, 1. So this could be a solution. So it's some kind of linear interpolation. So for that, what could I use for that? If I say the point, which is for example 0.75, and then say that my value will be multiplied by this point, so 0.75. So if it's 1, I will be equal to 75, and if it's 0, I will be equal to 0, of course. And if I say 1 minus 70, this value, of course, I will be equal to so right now I'm going from 0, 1, 0. What I want is simply change this. This might be the... Yeah, I think... this could be a great way to introduce something. Yeah, I might be able to use something. Okay. So instead of this, let me go check on the Git the proper solution, and I think it's on. No, it's not here. I think it might be here. Or even in the, maybe in Git and another project I might find something. So what I want to introduce here is the ability to use a gradient, really a ramp, a black and white ramp, to sculpt the curvature of our model. And basically it would be simply binding a texture to our a ramp texture to our compute shader, and using the normalized position in order to sample the value between 0 and 1 inside this ramp. And basically we can simply get rid of all the manual computation and basically sculpting our shapes directly in a gradient. So that could be a great tool. Of course, I could develop something, creating a gradient and binding the gradient, but I think simply create a texture and give us the ability to simply create a ramp directly in Photoshop might be better. So I was thinking about a compute shader I've made lately, and where is this one? User map, I think this is one. Yeah, this is this one. So let's add a uniform value, which would be a texture 2D, which is simply composed of a float 4. It could be a float 1 or 2 if we want to, if we don't want to use a 4 channel component. Body ramp, I will call this body ramp. Okay, so this could be my texture, and now I would need here, so this is my normalized value. Okay, and I don't need to scale this a little bit, so I could simply get the saturate value of this. Okay, and this one I don't need it, so I would need an integer, I think it's a uint3, which is the UV ramp, we'll call it like that, and this could be simply this could be something like that. So it's a uint unsigned int 3, and we would have basically it's the UV when we try to load. Let me reduce the music, it's too high in my hair. Okay, if you want to sample the texture directly in the compute shader, we will need to use an unsigned int 3 here. I think that's it. Yeah, and the last component will be 0, no problem, and the first is x and the second is y. So okay, because we can sample a 3D texture, for example, but here it's and it's a texture space, it's not a normalized space. So basically we will take the norm y value as our x value, so it's not rem, multiply by, and I will create a new uniform here, which would be a vector 2 and a float 2, sorry, a vector 2, float 2, and this would be our ramp size. Okay, so I would take this multiply by the ramp size dot x and 0.5 multiply by the ramp size dot y, 0.5 because I want to sample directly in the middle of the y axis. Okay, so now this is our new ramp. This is the UV of the new ramp, and we can sample the size. So this would be our ramp size, for example, and this could now be something like, I think, body ramp, if we call that name, yeah, body ramp dot load UV ramp. Okay, so when this is ready, I would need to create a new variable here. So yeah, this is the compute shader, so let's use public texture 2D, and this would be body ramp. Okay, and now we can set the texture here. So compute, we only need to bind it once, so we can bind it on update, so we would have the ability to change and update the body shapes, but right now it's not what we want. So let's use a set texture, which use a kernel in order to check where we want to put this, and it's body ramp, and it's body ramp, and now I can simply say this compute dot set vector, and my vector, I think it's a set vector, I'm not sure, but I think it's set, and my vector is the where is it, it's RAM size, it's a float 2, okay, RAM size, and this is basically a new vector 2, which has body ramp dot width body ramp dot 8, and let's hope we hadn't made any mistake on this one. Might be possible, but while it's compiling, I will open Photoshop on the side in order to create our little body ramp. Boom, boom, I need to sign in. Okay, value cannot be null. This is correct, of course, because I'm trying to compiling my compute shader while it's running, so this is basically correct. So yes, now I can create a new ramp, and let's create something like that. We could also, maybe I can simply resize this a little bit. We don't need something like 10 pixel might be sufficient enough. Okay, so what 15 just to see what we make. Now we will create a gradient here at 0. So remember, black is 0, white is 1. Okay, so maybe so I want something going from 0 to 1 because I'm remapping everything from the minus value to the maximum value, so not a problem having the 0 here. But so this is our 50%. Okay, so maybe we want, before the 50% growing a little bit, then we can simply change again and regrowth again, maybe really speedy, for example. And we could create we could start with something like that just to test if our hypothesis work. Okay, so in the ramp I will create a new folder. I will call this ramp 1D, and this would be ramp 1d.psd. okay, and let's save this one as 1d0.png, and we can now test if our hypothesis is correct or not. For me it seems to be working. Let's try to create something really different. I think the 0 here is not used, so let's create another ramp and let's modify this one. For example, let's create something like that. Okay, we could put more white here, for example, having some big foot. Okay, and this could be another ramp. I kind of like working with ramp because it's easier as a designer to produce something. So I need to change my ramp as ramp 1. Doesn't look like correct. Did we use our ramp? Of course no, we used the norm Y. We didn't use the ramp, so we haven't seen anything. Okay, so let's go back to the ramp 0. Okay, now we're seeing. So small, big, and a little bit big. Not enough. If I use this one, it might be big, small, etc, etc. So yeah, so now it's a new kind of gradient. It seems the belly it's on the right place, so belly here might be good. Let's try to add some variation into it. Okay, Could try something like that as around 2. So yeah, so now it's something interesting. I think this would be the last one because we need to go on the behavior directly. Okay. The head is correct for me, just I want to have a little bit more thickness in the leg. Yeah, more like that. This is basically what I wanted. I could now say something like that. Let's say we want more elements and we can reduce a little bit the min size just to see if we just scale everything. Yeah, it's too many elements, but it's quite interesting in fact. 005, and let's go back to 100 of sphere. Yeah, something like that is interesting. So now the bolts can fall, etc, etc. Okay, so we have everything. So let's focus on the first part. So how can we let's focus on the second part, which is the animation. How can we simply create something that will grow, then fall and bounce? The bounce might be the most difficult thing. Not as difficult as something really difficult, but more like that we need to make some physics into it, so simulate some physics using some gravity, etc, etc. So I think the first thing first would be simply focus on the growth. Okay, so let's focus on the growth, and the growth can be really easy. So we could create something, some kind of a 2-time timer. So I want on the first part having our sphere just whoop, and at the end it will fall and bounce. Of course the growth will be faster than the fall, so I would need some kind of 2-timer. And I really don't want to change everything, so to create multiple timer and something complicated. So I think I would simply create something more simpler than that, and I will rely on the fact that we only have 2 states. First of all, growth, then fall. So 2 states. So with 1 timer I can get 2 states by simply counting the loop. So as you remember on the A loop, on the loop here, so in this part we're computing the the loop number 0, 1, 2, 3, 4, 5, etc., etc. So we can simply say if modulo of this loop is equal to 2, so it's an even number or 2, will be on the growth or on the fall. At first the loop is 0, so of course if we change the loop, so it will grow or not. So let's try something like that. Let's not change this element right now. So here we are simply having something here. So let's try something like that. So let's try to create something, some kind of animation on the growth. Okay. So let's say animate the growth. So basically the animation of the growth could be something like that. Float growth animation, and this could be, and I would use a ternary operator. So if a loop, which is the actual loop, okay, modulo the 2 is equal to 0, okay, so it's if it's an even number, then we have a growth. If not, we have a fall. So if not, the growth animation will be equal to 1, so no growth. If the growth is ready, then we will fall. So 1, we will fall. And now here we can simply taking something like what do we have here? We have this here, little here, we don't need it. This, maybe we can use this one. This one we don't need it. Remap alpha time, we don't need it also. We can use this little value here, okay. And now I can say that the size, if I want to animate it, will be equal to this multiplied by this little guy here. In the sake of our debugging situation, I would simply say that every instance would have the same max time and the same time value. So no offset, no offset in the random, no random offset in the time, and let's say max size of 4 seconds, just for the sake of it. So now I might have an animation, so 4 second growth, then nothing, growth, then nothing. So let's try that. Growth, nothing. Growth, nothing. Okay, so growth, nothing is working, of course. So you may notice that it's something more like that. It's more the inverse. So the first, at first when we click play, if you want to have the growth, yeah, the growth happen on 1. We also need to change the position where we can change the position. We can change the position here. Okay, so we can re-render the position. We can change this little guy, this index. Okay. We will check with the index later. So the growth is okay. Now let's check how we can have some growth. Okay. In fact, we need to define something more differently, I think. Or something more like a behavior, something like a if else. Okay, so let's try something like that. If a loop modulo de 0 is equal to modulo de 2 is equal to 0, then here we are on the fall. If not, the size is multiplied by by its growth. Okay, so this is the growth. Okay, not a problem. And we could also say that if not, then the position, of course, is equal to the position directly on the buffer. Okay. So I will need to create something like position so flow 3 position would be equal to the last value of our transform matrix, so 3 1 3 and 2 3. Okay. Okay, so I might made a mistake, so let's check on the shaders. Another one, I think is this one. No. 031333. Okay. I've used the estimate. This is why my my define position is not working. Okay, let me change the music because it's not really interesting right now, so let's use something like that. Let's have rock. Okay. So now the body is fixed and it can fall. Okay. So now we can find a way to be falling our little guy. So this one we don't need it, so this would be some kind of definition. So let's try this definition here, because of course this is our main position. Okay. So let's remember some quotes about Kinect has cut, but the camera is still live. Why? Look like this stream is, oh yeah, Kinect is unplugged. Okay, let's try to relaunch this little guy. He's reloading. Okay, we are back on live. Okay, not a problem. So yeah, what I will think is we have the time management. We have this one right now is not really used. This is basically the size management. Okay, this growth animation, we don't need it. Okay, okay, so basically now we can identify a vel, because I think I've put some vel somewhere. Yeah, transform vel, but we don't need this one. Okay, right now we don't need the vel. So various thing. First of all, we will need to add some force into it, and if I remember correctly, native.axt.education, if I remember correctly, the course I've written on the my website is not loading. Everything decides to be complicated tonight. Okay, so there is something like that. I think it's acceleration is equal by the force divided by the mass, but not in gravity case, which is our case, of course. Vel plus equal acceleration, position plus equal velocity. Okay. And now it's the direct from Instagram, which has closed. Everything decides to stop tonight. You know what? I will not relaunch a live stream on Instagram tonight, so I could only focus on the code, because it might be a little bit not complicated, but not complicated, but a little bit tricky. So yeah. And we need to save the velocities. That's the main part. We need to save the velocity, of course. So the acceleration is the force divided by the mass, not in gravity case. The velocity plus equal the acceleration, and the position plus equal the velocity. Of course, the velocity has a limit, so clamp. So h So we would say something like vel dot clump something like min max, or a simple clump. I think it's taking the, so vel would be equal to a clump value of the velocity to a mean speed max speed. Then the position will add the velocity. So that would be our fall. Then we will use the check edge in order to find the way where we're bouncing. So let's try that. Okay, so let's create some gravity. Okay, so that's the definition. So let's create float 3 gravity. So the gravity is basically equal to a float 3 of 0, 1, 0 at first. Okay, after that we might create another fourth, but okay. I think we will add also to check some friction, but okay, so this is the gravity. After that we could say maybe in the opposition we would have a velocity, of course. So let's say that at first the velocity is simply a vector 0, 0, 0, 0. Okay. So float 3 vel, it's our velocity. Okay. So let's say that float acceleration, float 3 at first is simple a float 3 of 0, 0, 0, then acceleration plus equal gravity. I prefer to write it like that instead of simply binding the gravity to the acceleration, because we would add another fourth, I think. And then vel plus equal acceleration, then vel would be simply a clump value of the vel between, let's say, something like a 0, 1, for example. If just right now, we would change like this later. Then I said yeah, acceleration will be go back to 0 at last, so not a problem. Then the position will be plus equal the vel, and now I need, of course, to put the position directly in the transform, so this is not a problem, but I would need to change this by binding the velocity here. So I'm also taking the velocity, saving the velocity. By saying that, I might having my sphere falling. So let's reduce a little bit our gravity by saying something like minus, so 0, 1 and 0, 1, and I think the gravity might be something like an invert. when we put a value of 1 it would be too much, so now it's not enough. Yeah. So yeah, as you can see, it's working. So if I invert the value, let's try. So yeah, I think it might depend of I think it might come from the clamp value. Let's try that. Yeah, okay, so that's the clamp value. The clamp value it doesn't limit. So let's say how the limit is made. Yeah, that's okay. So it says that something like we could limit the velocity by saying that if length of vel is superior to, is upper than 1, okay, then we would make something. If not, we will return length. So then we would say something like normalize vel multiply by 1, for example. So this is my max speed, okay? This could work, I think. Okay. Of course, I can say that the velocity can reset the velocity to 0 when the the vel could be basically a flow 3 of 0, 0, 0. Okay, so we have the base. We still have a little problem here, but let's resolve that. We have this original scale math. Here we have the scale, the vel and the position. We use the oppose here on our structure in order to store the velocity, okay? Do we use the original scale? I don't think so, because we simply change the we are simply changing let me check. My main problem is this, the position. So the position is not fixed, so the better way to do that would be to add another element, but let's do that. In fact, this is the original pose, and I would add a new value which would be the vel. Okay, and then after that I would simply say vel, of course, and then I would say o.oppose, so dot vel, and that would be simply equal to the position dot x y and z. Okay, and this is vel. Of course I would need to simply, in my compute shader, in my shader, it's the 11.6, so I would say the 11.17, 11.06, this is this one. We need to add after that the vel struct, because I need to get the same value. I forgot I saved it on the same, so float for vel. Let me get this, save this, take this and save as 17. Okay, 17. Then in the compute, after oppose, I've got the vel. Okay, so the vel is property dot vel, and oppose it property dot oppose, and I could use the original pose here, so not a problem, of course. Okay, oppose.y, and now I can change the vel here, and now I think I would not have the jiggy bubble. So what we need to do now would be to simply create some kind of a check edge. So something like simply if position dot y, and we need to know if the balls bounce on the ground. So if we take position dot y, and if we check if it's under 0, basically it will return yes if and only if the center reach the ground. But as the ball has some depth, some thickness, some diameter, we need to offset this. So it's not position dot y, but it's if position dot y minus scale, of course. So we could take the scale dot y, the size dot y, because size x, y, z are the same. So we could simply say if position dot y, basically I think it's right. So if position dot y minus the size would be below 0, then we would need to simply multiply the velocity by -1. So basically this is only creating some kind of bouncing during the fall. Okay, so now it's bouncing every time. So we need also to add various things. If you want some kind of bouncing, a limited bounce, for example, we need to add some friction. So friction works with gravity. The main idea of the friction is every time an element reach a surface with a force. So you see my fist going on my hand with this this velocity from the fist to the hand. The fist will also receive force, an inverse force of the hand to the fist. So this is basically Newton's law, thing that for every force it has an opposite. So we could create a simple friction element. Okay, so we need to create a new force. So this would be, let's say we would use a simple coef. So I will use some constant for that. Okay, so let's create a basic constant. Would be 0.01. The main idea is to reproduce the friction of the end. So float 3, which is the up vector, it's basically, so this is the normal to the ground. So the normal to the ground is a float 3 of 0, 0, 0, and it's 1 on the y-axis, and this is the up. So the float 3 I think the up vector might be a constant and not it's like a normal, you know, but it would be a constant because we will use it as a multiplier, as we only want to use on this. Yes, it might be enough. So the friction would be something like up multiplied by the coefficient, and now we will create our vector. So this is our friction mag. So this is the magnitude of our friction. And now we can create a friction vector, which is basically the velocity. So let's say vel multiplied by minus 1, and this would be of course normalized because we only want the direction, so we want the inverse of the direction. So remember, the friction is the inverse of the force I exert with the feet to my hand. So basically it's going from the hand to the fist. So I taking this vector, normalize it, okay, then I will multiply this normalization by this magnitude. So this would be the force of our element. And now I can say after this that acceleration will be, to the acceleration we will add the friction. Okay, so this is the friction. Let's try this now. Seems to be not working. Because I think we might simply change this by a simple coefficient. Remember that we have some smaller value. But if I say so, okay, and if I add the friction to the acceleration, oh, I've made a constant. It's not a constant, it's a float 3, of course. Let's try that. Okay. It's kind of strange. Let's say if I taking this inverse of the float 3 val dot xyz, let's try to check if it's because of the friction or not. Let's try to add some wind into it. Okay, something like a wind going from this, let's say, to 0, 0, 1, for example, and this would be a wind, and say acceleration plus equal wind. Okay, so I will need a little less wind. I think I would need to add the acceleration and then multiply everything, so okay. Let's create that. After this I will add an acceleration. After this let's add the acceleration. This would be the acceleration. Okay. L dot x. Okay. So val plus equal acceleration. Then I need to say acceleration equal 0. No, we have the same things. This is strange how the things are. Maybe I could say something like that. Is equal acceleration. The bond system is really strange. So it's working, but strangely. And if I put everything inside it here, the way it's bouncing, it's really disturbing. Usually I apply force yeah. Now I remember what's the problem. The problem is I basically changed the velocity, but I don't want to change the whole velocity here. I want simply to change the velocity.y. So basically my wind is correct. It's my edge which is not. Okay. So that's the main idea. Okay. Now let's say that so acceleration plus equal gravity, acceleration plus equal wind. I'm only inverting the, so yeah, so now it's better. So let's try something like float max speed would be equal to something like 0, 0.1 for example, just to have a limit. If val is better, is upper than this value, Okay. Let's check if it's working. Yeah, it's working. Okay. So yeah, the max velocity is really important to consider. So now you can see how it's behaved. Okay. So we forgot something about the wind. So let me just find the proper value for the max speed. Okay, perfect. Yeah, we forgot something about one thing. It's basically, in order to apply a force, it's depend on the mass of the elements. So basically, usually if I want to apply a force to the acceleration, I would say the force divided by the mass. So let's say that the mass is basically one component of the size. So this basically applies to the object, but it doesn't apply to the gravity. So the wind is ready to speed because we have the same wind as the gravity. So yeah. So now we can try to add the friction, and the friction might be also divided by the size. So let's multiply by that, and let's change this constant by something less than the wind. Okay, so the friction is clearly not working. So if I invert the friction, let's say something like that. On paper side, the friction seems to be good. If I'm rereading the course I've made for this one, so we would add something like that. So the force is divided by the mass. Okay, so we apply the wind, we apply the gravity, not a problem. But the friction, what is it? It's basically the velocity divided by multiplied by -1 in order to invert it, and then we're multiplying by this. So why we cannot have this? We can also simply don't use this one for the sake of our experiment. Okay, So now something that we might also be useful is to change. So let's say here friction has a problem. We hadn't and we haven't time to find it. Okay, so it's a quick note to myself. Yeah, so what I was thinking also is each time we're changing the loop, which is here, we need to know if we want to change something. So for example, we're on the fall, so we don't change anything, but on the growth part, which means if a loop modulo 1, so we might be able to change something like a random index. So you know, or not, we can also try this. In fact, loop per index per this might be quite good, in fact. Which is this. Because this change for each loop. Oh yeah, but if it changed for each loop, we need to change another something else. So this is what I want. I want to change the position for each loop in order to recreate a new persona. So if we are at the start of this scale, the growth, then we will find a new random per loop using the index. Then we will define a new index, which is this, okay, and we would say that property.x is basically equal to this index. So we could redefine everything. And now we have a new so we would also need to redefine the original pose. Okay, so the original pose will be something like because we use it and because we change everything, the original pose we use in order to define the size of our element is not good. So now we can simply say something like that. Okay, so now the new original pose is redefined also. And we've made some mistakes somewhere. It's a XYZ position. So of course we simply try to bind a vec4 to a vec4. Oh, again. Property.oppose is equal to position.index. Where did I make a mistake? If I push OK, this is what we got. Okay. And then why this property.oppose is equal to oppose? So why if I say something like that, it's not feasible? Oh, it's a float 3 here. I need to say it's a float 4. Of course. Index and 1. I cannot. Okay. Okay. So next things would be also to be decreasing the size according to the normal value of our time. So we could change a little bit and say something like float is full and use out quad of the norm time, of course, again. Simply that. And now we could say that the size, which is it, decrease the size along the fall. So size multiply and equal by the is fall. Oh, I need an invert of the normal time. Okay. And at last we could simply reuse the offset on the time and see what's happened. And as you can see, basically we are falling, we are losing some of the, let's try with less elements. Basically we are losing some of the balls. Well, some of them seems to be appearing really quickly. So why? Some of them doesn't seem to fall, I don't know why. Because when we use that, we were having the same time for each one of them. Okay. So does it come from the randomness? Might be. might come from something else. Let's try to change this. Yeah, it looks like a timer problem. Okay, let's reactivate this and reactivate everything. Maybe it's come from that, because it seems to going from the loop. Yeah, it's come from that. If we don't resign this, I don't think it would be a problem. Okay, if we want to bring more realism to this little scene, we could do various things. First of all, we can simply reduce a little bit the wind, or increase the mass, for example. But reducing the wind might be better. And we could simply try to add some rotation into it. The friction is really a problem. really don't know why I have this problem on the friction. Yeah. Okay. If I don't normalize the vector, it seems to be working, adding the friction. So as you can see now, the friction is working. So we could use something like that. So I don't know why the normalization of this vector would be. Let's get rid of these parts. Because as you see, the frictions give us something to jiggy. So I'm not convinced about it. Oh, maybe we can also say something like that. Let's say that position dot y is equal to, because if it's on too small, if on two frame the gravity is not enough to going back, we might ending having some weird bouncing. So now the bouncing seems to be less jiggy. Okay, so we could go back with our friction, adding a little bit of this because we're avoiding that. Yeah. Oh, of course I've made also a mistake. I'm not reaching the ground because I'm checking if we are below the size, but it's a sphere and we are at the center, so we need to check if we are below the size divided by 2, so multiply by 0.5. So now it's, yeah, no, so now it's a proper gravity system. Okay, we can reduce a little bit the friction to get some wind. Or the friction might be enough in fact, but we simply need to increase a little bit the wind, like the gravity. Too many wind! No bouncing! So the last part would be yeah, now it's good. So the last part would be simply rotating the shape, rotating the sphere. So we've made that also on another experiment, and let's try to check which one it was. Bam, 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 bam. Maybe we can change a little bit some size or not. I'm not sure about that. How do we define the size? The size is basically defined on the ramp. No, we will not redefine the size. It could be great to change and having more differences, but no. Let's try to finish the first part and then we will focus on the other. So it was why do I have, yeah, so this is 16, 15, 14, 13, 12, 11, 10, 9, so it might be on the 9. So let's check the 9. Computer 9, compute 9, and it's, I think it was 902 where we rotate according the velocity. So this was our rotation. Okay, so we can take it and try to rotate also the shape. Rotate the shape according its velocity. Basically, we normalize the velocity, we take the up vector, we define this, we take this, and we define that. So at last we could simply say that this could be equal to rotation, and this is property.rotmat, I think. It was something like that. Dot rotmat velocity, the scale, and we've made identifier rotation, of course, because I need to declare this at first. And let's say we'll declare here, so float 4x4 rotation is equal to this dot rotmat. Okay, so we could reply it. Let's check. So now it's footing. And we haven't put any random rotation into it, so let's put some random. Oh, it doesn't seem to have some random rotation. Why? The mesh controller also has a rotation here. Maybe we could define a random rotation around something like that. I think using a random value, for example. But I'm quite okay. So let's open the random element. Do we use the original scale, for example? I think the scale is never used. If so, yeah, the scale is never used. So maybe we can put the original rotation directly into this. Or simply create a new one, in fact. Yeah, we need to define a random angle. So let's say float R&D angle could be something like something we have, in fact. Which can be something like that. This little value here. This multiplied by a constant, so let's say p. So multiply by this by 2. So this could be our random angle. Let's check if we have something stable for that. No, not at all. Oh, because we don't have axis. So let's say something like I need a new random element, so in the script I would put some noise. Where are my noise? Yeah, noise. So let's try something like that. Let's try to generate a random vector, for example. So float 3 random axis. This could be simply a float 3 of some kind of random. So let's say random. We use the same thing. This if we have this, we could simply say that another random plus a value then another random plus another random value. So this would be a random axis. Multiply by 2 minus 1 in order to get simply something in all direction. No matching. I don't have any matching. I didn't made a mistake. Open, open, close, open, close, open, close, close. For me it's good. So why did I make a mistake? Yeah, of course I made a mistake. Of course I've made a fucking mistake. If I say something like that, this would work. Yeah. This is kind of strange that the size has changed, because it's only a rotation, so and if I put something like that, this would be correct. But I have something which is plain. Seems to be an effect on the size. Did I put something on it? Okay. Where did I make a mistake? A scale is not used, of course. I might have made a mistake directly in the rotate around. In the matrix, sorry. No, we still have some shape which is totally broken. No, I still have some elements which are basically totally explode. and this is really not correct. So why do I have something like that? What mat? SC mat, so not a problem. Do we change anything inside the shader here? No, rod multiplied by the scale. So it's clearly not coming from this. Maybe we need to have the same value. Oh my. This gives us clearly the same value. Oh, this ball is really, when I take a random value, it's clearly you know what, let's go back to the original. We clearly have a problem here. It's not a problem here, but we have a problem here. Those hot scale is used, hot scale is never used, and as this, so I would basically put my rotation in the hot scale just to be sure. Okay, so I will name it ORT mat. So if that rotation would be equal to ORT mat. Okay. Okay, it's okay. So let's add a little bit of variation. Let's say something like 100, 100, 100. Sometimes it's stop the okay, so we need to put some fade into it. Which is the alpha test, but we could use something like a smooth step of something going from 0 to alpha test in dot data dot y, and now in the compute I could simply set that in the data dot y here basically is equal to 0, but this would be equal to the norm time, my. Okay. It's basically the inverse. What the fuck? What the fuck? Why does the gravity doesn't work anymore? Okay, so this is working. Let's add that. Okay, this is working. Okay, let's add the size change. Okay, and now if I add that, we really have a problem with this kind of rotation. I don't put the rotation. So if I set that, Merci beaucoup. J'avais pas vu le chat. So, le quaternion et l'ensemble des quaternion de l'ensemble des rotation, rotation fois signe de rotation angle, donc ça c'est bon, ça c'est mon quaternion. On est d'accord. I think this might. I think I forgot a part here. HLSL quaternion 2 matrix. This I can do that, but I want to convert. I think this would be good for tonight because we don't see a little bit. We don't see fully the error, so I think it's quite good. For me, I can see the error. So when the ball don't fall, it doesn't have its proper rotation and also you can see. So I also have some glitch here over some Z elements. Some of the elements are glitching, so this I think it might come from the fact that we are reassigning the position. So okay, not a fact. And if we apply this, we would see that we have something. So we still have some little bug into this one as the other one, but it's kind of way for us. As you can see, we still have some glitches also. So it's a way for us to, how can I say that? We could create a 3 states, so something like a reassignment state, where when we reach the end, we wait until it's reassigned, like a full loop, okay, to just replace everything, etc. So we will not have this kind of little glitch, because I don't know why we have this glitch, because the size is basically based on the gross, so and this is also the same thing. So we have this little glitch, okay, and we also have the problem on the rotation, and we still have this problem. I've seen this problem on another experiment, so I think it might come from another things. So I will check it later. So let's say it's okay for tonight. I hope you enjoy this one, and see you tomorrow for another one, and maybe we will try to correct our rotation system.